Okay, the very first thing I want to say is that we have to understand what you mean by rate. Now, you all know when we say that somebody is traveling at 40 kilometers per hour, you come across this expression, 40 kilometers per hour. This actually means in 1 hour, right, he covers 40 kilometers. And so this is what it means. 1 hour it covers 40 kilometers. So this here is your speed. So in 5 hours, he will cover 5 times 40. And if you say T for time, T hours, you will cover in 1 hour 40. So in T hours, it'll be 40 times T, which we write as 40T. See? So this is your speed, right? So your speed, if you use S for speed and D for distance, this is your D, then you'll see that the distance is equal to speed as 40 times time. So this is the basic formula in all these. The distance is equal to speed times time. But you don't have to worry about formula. You just, if you translate this, you'll see that it'll just come naturally. But the product of S and T is, so you can get other formula from them. The speed is equal to distance divided by the time, or the time is distance divided by speed. Because if you multiply these two, you will get the distance. All right, so that's the background to this. Some of you may want to take photographs, pictures of the screen before I clear it. And you're quite free to do that. But you have to do that quite quickly because I'm not going to wait. Okay, now you've got Tom was jogging at a constant speed of 10 kilometers per hour on a straight road. All right, so Tom is traveling. His speed is 10 kilometers per hour. In other words, in 1 hour, he travels 10 kilometers. And so as I read, I'm recording the information. And that's a very important thing to do. Don't read everything one time along a straight road. Now, Jerry, jogging at a constant speed of 12 kilometers per hour, is 600 meters behind Tom. So you have Jerry is here somewhere, is behind Tom, and he is traveling at 12 kilometers per hour. But he is 600 meters behind Tom. So this is the story. Tom is here, Jerry is 600 meters behind them, both traveling the same direction, but he's traveling faster, 12 kilometers per hour. So the question is, how many minutes will it take Jerry to catch up with Tom? He will catch up because he's traveling faster. So sometime or the other is going to catch up with him. And the question now is, how long would it take him to do that? All right, so there are two ways of doing this thing. You see, he's traveling at 2 kilometers per hour faster than Tom. So if you want to put it another way, in 1 hour, Jerry is 2 kilometers closer to Tom. He's traveling faster. So one is traveling at 12 kilometers in 1 hour, the other is doing 10 kilometers in 1 hour. So therefore, he would have been is closer to Tom in in 1 hour. But the distance between them is only 600 meters. So you want to know how long would it take to cover the 600 meters. Okay, so let's convert everything to the same thing. 2 kilometers is the same as 2,000 meters. 1 kilometer is 1,000 meters. So now 2,000 meters, you would take 1 hour to cover 2,000 meters. So the question is, how long would it take him to cover 600 meters? So it's a fraction, 600 over 2,000. And this is 1 hour. So we might as well convert that to 60. Because the question was, in how many minutes? So you convert the hour into 60 minutes. So it'll be a fraction of that because you'll cover 2,000 meters. I'm sorry, this is 2,000 meters in 1 hour. 600 will be a smaller bit. The actual fraction is this. So now you can cancel all these, and you'll see 2 goes into 6 3 times. You don't have to multiply all these things, and you got 3 times 6 is 18. All right, so you put the fraction and you cancel off all the tens, and you're left with the 18. Now, another way of doing this, so the answer is 18. Another way of doing this is that you say, suppose it takes 3 minutes to catch up. All right, so in those 3 minutes, Jerry, now you got the time now, you see? So Jerry is traveling, the speed is 12 kilometers in 1 hour. So Jerry covers, right? So if you say 12 kilometers 1 hour, it'll be 12 over 60 kilometers in 1 minute. Because in 1 hour, that's 60 minutes. He covers so much. So in 1 minute, it'll be 12 over 60. So therefore, he covers in T minutes, he'll cover 12T over 60 kilometers. And Tom covers similarly. It's the same time now. We are looking at the time to catch up. And you got 10T over 60. Right? But then the distance between them, one does 12T over 60. The other is 10T over 60. So the distance between the two is the difference between these two. Okay? And you want that distance to be 0. No, you want that to be 600. Sorry. Wait a minute. I'm sorry. I'm getting very confused here. Um, the distance between them is 600 meters, and you. Okay, let's just ignore this. Sorry, let's not do it like this. Just be satisfied with this one. Okay, I can't understand. Um, what I'm doing wrong here. All right, I'll probably come back to this. I don't want to take your time. Okay, so the so this is how you do this problem. You imagine that the one person is traveling at 2 kilometers per hour faster than the other person, and then you see how much time it takes to catch up with him. So let's get on to the next problem. All right, the next problem. I hope you have looked at these problems because I keep appealing to you to look at the problems before you come to the class so that you can appreciate it. Okay, so this one here, you've got Adam and Betty travel from Adam's house at the station to Betty's house. Just one moment, please. All right, so you got two people. One is Adam, the other is Betty. They travel from Adam's house at the station to Betty's house. So both of them, they start together. Okay, so let's just see what's going on here. They are traveling from one point to another. Let's just draw a line to indicate that. So Adam and Betty, Adam, and they're going from Adam's house. This is his house. That's at the station, and this is Betty's house here. All right, so they both start together. All right. Now, it says here that Adam travels by car, or Betty first takes a 30-minute train ride and then walks the remaining distance. So what Betty does is she travels by train, and then the remaining part she walks. Okay. All right. It's a 30-minute train ride. Okay, so she takes 30 minutes for this, and then she walks to a house at 5 kilometers per hour. Right? So the speed here is 5 kilometers per hour. But she only travels 1 kilometer, right? From the remaining 1 kilometer. So she walks at 5 kilometers per hour, but the distance she covers is 1 kilometer. In 1 hour, she does 5 kilometers. So how long will it take her to do 1 kilometer? It will be 1/5 of an hour. and 1 hour is 60 minutes. So 1/5 of 60 is 12. So she takes 12 minutes walking because she travels at 5 kilometers per hour. Okay, so in other words, Betty takes altogether, it takes her 42 minutes to reach her home. So what does Adam do in the meantime? Adam drives a car by road. So Adam travels by car. I'm not very good in drawing these things, but anyway. So he's traveling by car, and the road is 84 kilometers long from the station to Betty's house. So now we know what the full distance is. It's 84 kilometers. So Adam, he travels a distance of 84 kilometers. And now you want to know how fast does he have to drive to arrive at Betty's house at the same time as Betty? All right. Now let's just try to understand that. He's traveling at 84 kilometers per hour. 84 kilometers in 60 minutes. Right? And he wants to arrive at Betty's house at the same time as Betty. They both leave together. Betty takes 42 minutes. So he will also take 42 minutes. Because they reach the home together. They leave together and they reach. So Adam also will have to take 42 minutes, as Betty does, because they reach at the same time. So what have we got here? We got that in 60 minutes, right? Adam would have traveled 84 kilometers, right? And then in 42 minutes, no, we don't know what his speed is. We don't know what his speed is. Sorry. So Adam's speed will be distance divided by time. So the distance he travels is 84 distance over time. Okay. The question is, you must give the answer in kilometers per hour. So let's convert everything to kilometers and hours. So the distance is 84. And the time you would take in hours, that's 42 minutes. So that's 42 over 60 hours. Then you must convert that into minutes. Convert minutes into hours. And now 84 divided by that, the distance divided by time. So it's 84 over 1 times 60 over 42. And you see 42 goes exactly into 84. And the answer will be in kilometers per hour, because we converted into kilometers here and hours here. 2 times 60 is 120 kilometers per hour. So Adam's speed will be 120 kilometers per hour to cover that distance of 84 kilometers in 42 minutes. Okay. You could have said, yeah. Okay. So so this is the solution to this problem. You see that I used this formula once. The speed is distance divided by time. You know what the distance is, and you know how long it takes, so therefore you can work out the speed. Okay? Okay, otherwise you could have said speed times time equals distance, and that might be a little bit easier, because then you will say that speed times time is distance. Is speed, we don't know, S, the speed, that's what you need to calculate, multiplied by time. Time is 42/60. Hours equals 84 kilometers. Otherwise, you could have said time in minutes. You could say 7 times minutes. So S times 42 is 84. So therefore, S is 2 kilometers. But per minute, because so in 1 minute, he would have traveled 2 kilometers. So in 1 hour, it'll be 120 kilometers. You could have done it that way. If you just watch the units, kilometers to translate to meters, minutes to hours. So you have to get everything on the same page. Okay, 2 kilometers in 1 minute means in 60 minutes, which is 1 hour, it will be 120. See, you have to work out all these things logically. All right, let's get on to the next problem. Now, Erika noted that a train to Musenberg took 8 minutes to pass her. Okay, I already got the diagram here to make it a little bit easy. So there's Erika here, standing here. And she saw that the train to Musenberg, there's Musenberg, and imagine that this is a train. She's standing here and it goes in this direction, right? And it takes 8 minutes for the train to reach the spot here like that, right? To pass it. Okay. So we don't know what the length of the train is. They give the length, but I'm just going to call it X and Y at some point or the other. So I'm going to call this X. So in 8 minutes, this train would have covered X meters. Right? So the train would have gone in 8 minutes. So the speed of the train in 8 minutes the train covers X meters. Now, X is the length of the train. So we have to write down what X is. X is the length of the Musenberg train. I'm going to call it M train. That's the train which is going to Musenberg. Right? Right. Now, but a train in the opposite direction, so there's another train which travels in the opposite direction, and that is traveling to Cape Town, but it took 12 minutes to pass her. So let's call the length of the Cape Town train, we'll call it CT train. If you call it Y, it means that it took 12 minutes to pass her. So in 12 minutes, the CT train covers Y meters. It took 12 minutes to pass it. So what does all this mean? It means that the speed, let's call it S, and we'll put an M here like this. This is the speed of the Muizenberg train. Is distance over time. So it's X meters over 8, but this is now meters per second, meters per minute. Well, because it takes X meters to travel 8 minutes, so therefore in 1 minute, it'll be X over 8 meters per minute in 1 minute. And similarly, the Cape Town train, the speed of the Cape Town train is Y over 12 meters per minute. I'm just recording the information as I'm reading it. Right? I haven't come to the question yet. I'm just recording the information. This is the way you do mathematics. Do it slowly and systematically. Right? So we've got the information. We translate that information to get the speed of the Muizenberg train, the speed of the Cape Town train. Now the trains took 9 minutes to pass each other. Okay, now this is an interesting thing. So now what do you mean by passing each other? It means that if Erika is standing and watching these trains, okay, suppose the one train we'll put the trains next to each other like that, and then you do that, right? And this is the Muizenberg train. And this is the Cape Town train. Now, they take 1 minute to pass each other. Now, what does that mean? Or 9 minutes. So now, let's just imagine you've got a point here. The front of the Muizenberg train, right? And suppose this is the front, we'll call this point B, is the front of the Cape Town train. So A and B, the distance between A and B in the beginning is 0, right? When Erika is watching them, this thing is, the front of the screen just meets the front of this one. So the distance between A, B in the beginning is 0. But then what happens is, after 9 minutes, the A is here now, the front of this, and this is 9 minutes. While the B is there, because this train is going this direction. But it also takes 9 minutes. So the distance, at this after 9 minutes, the distance between A and B is X plus Y. A is the front of the Muizenberg train, and B is the front of the Cape Town train, right? And after 9 minutes, the A is here, and the B is there. So the distance between them is X plus Y. Because we know that this is, one of them is Y, one of them is X, right? But remember, the speed of the the train is X over 8 meters per in 1 minute. So SM, or the Musenberg train, the M train, in 1 minute it travels X over 8 meters. So therefore, it would have traveled in 9 minutes. It would have covered 9x over 8 meters. The M train, this one here. This part here, right? It would have covered 9x over 8 meters, while this Cape Town train is traveling at y over 12 meters in 1 minute, and in 9 minutes, it will travel 9y over 12 meters. Right. So on the one hand, you've got that the distance, so therefore AB is also equal to 9x over 8 plus 9y over 12. Right? Because A will go in that direction, B will have gone in that direction, and the distance between them would be 9x over 8 plus 9y over 12, because one travels the opposite directions. Okay, but we also know that that is equal to x plus y. Okay, so you can just take a photograph of this if you are inclined that way. And I'm going to see whether I can get a whiteboard to okay. David, can you see this? The whiteboard?
Yes, Prof, I can see that.
All right. So you got AB on the one hand is x plus y, and on the other hand, it's 9x over 8 plus 9y over 12. Okay, so you got this equation. It's also given. Okay, I'm just going to just write down these equations. So you got a common denominator 8 and 12. Let's get rid of the fractions. So you can multiply by the LCM of this is 24. So multiply both sides by 24. Get 24x plus 24y is equal to, if you multiply this by 24, get 27x plus 18y. I don't like fractions. I usually, whenever I got an equation involving fractions, I multiply by the common denominator. So you get rid of the fractions. You flatten, what I call flatten the expression. And so now you can bring all the x's to one side. Okay, by the way, the question also said that one of the trains is that y is given that y is equal to 150 meters. I'll show you that later on. I'll go back to the question later on. We know that y is equal to 150 meters. So let's bring all the x's to one side. You have 27x minus 24x. Bring the x's to this side. And this is 24y minus 18y. Bring the y's to one side. And then this is 6y equals 3x, 27 minus 24. and therefore you can still divide by 3, and you have 2y is equal to x, and y is 150. So therefore x is 2 times 150 meters. Everything is in meters, and that gives you 300 meters. And this is, remember, this is the length of the Musenberg train. I should have looked at the question and I didn't do that. It's very bad of me. Let's just go back. I calculated the length of the Musenberg train, given what the Cape Town train, what the length of the Cape Town train is. So let's just go back to the question. Assuming each train, and given that the train to Cape Town, no, that's y, right? Y is 150 meters long. Right? This was given. What is the length of the train to Musenberg? So I've calculated. If this y is 150, I got an equation involving x and y, namely x is equal to twice y, and then knowing that y is 150, so that gives me x is 300 meters. So the answer to this question is 300 meters. Okay, you say it's not an easy question, but I want you to think very carefully about the way we have done this thing. How do you translate the fact that the trains pass each other in 9 minutes? That is the tricky part, right? That is the tricky part. So you use your symbols x and y to get 2 ways in which you can calculate the distance between them. And then once you equate them, you get an equation. All right, so let's go on to the next question. Okay, the next question says, athletes A and B run at constant speeds in opposite directions around a track. All right, so they don't tell you what the shape of the track is, but I presume it really doesn't really matter, it seems. So we can just say it's a circular track. The reason is I'm going to draw a circle. Okay, let's make it a nice elliptical track. All right. Okay, so let's just draw the track and see what the information is, what's given. So it's given that these 2 athletes, they run at constant speeds around the track, but they run in opposite directions. Okay, so they begin at the same time from the same point. Okay, so let's suppose this is your starting point. And A and B start here, and they run in opposite directions. So suppose A runs in this direction, and B runs in this direction. All right. Now, for every 2 laps that B completes, A completes 3 laps. And this whole thing is called a lap. Right? So let's see now, where are they? You see, they are running each other. At some point or the other, they will cross. And the question is, how many times do they pass each other during A's first 10 laps? Okay, let's just follow A's trajectory. He goes around this way, and B goes around this way, and they pass each other. Okay, the first pass. Okay. Now, what can we say? A is traveling for every lap, 2 laps that B contains. completes 3 laps. So A is traveling faster, right? Is traveling at 1.5 times the speed of B, because it does 2 laps when A does 3 laps. Okay, so we want to take this entire distance here, your lap. We'll say it's one kilometer, whatever. So what is this piece as that piece? And this piece here, A's piece will be smaller when they first meet each other. A is more, so it will be actually B. A is faster. So you got two. The ratio. Let's put it this way: the ratio of A is to B is 3:2. Right? That's the ratio of the speeds. S A to SB. Speed of A to speed of B is 3/2. Right? So, in other words, A's speed is 3/5 of the total, and B is 2/5 of the total. Right? Why am I saying that? I'm going to say that this part here is 3/5. He would have traveled 3/5 of this lap, while this fellow would have traveled 2/5 of that lap. Let me just put this X in a more. This distance here is longer, 3/5, and this is 2/5. Okay, he's traveling slowly, right? So they meet here. This is the first meeting point. Right. Okay, now they will meet again, but now having you can from this point onwards, you can say that they are starting here because both of them are together here at this place, right? First meeting point, and they continue to do the same thing. This fellow continues to travel this way, that way. It's like this whole thing here is being repeated, but from this point onwards, right? So then A would have traveled 3/5 of a lap, right? When they meet at the first meeting, A travels 3/5 of the lap. Now, the question is, so then the second meeting, A would have traveled 2 times 3/5 of a lap. Each time they meet, A would have traveled 3/5 of a lap because he travels more than the other fellow. So like that now, they say, how many times do they pass each other? So at some point, right, when A does 10 laps, right? So you've got, if you suppose they pass each other on the nth meeting. At the nth meeting, it'll be n times 3/5 of a lap. See, first meeting 3/5 of a lap they will meet. Second one they meet at 2 times 3/5 of a lap, somewhere there, and third meeting and so on. So, but the A would have covered 10 laps altogether. So you got n, the number of times they meet, times 3/5 of a lap is equal to 10 laps. But, so what is n? Now you can actually calculate n. N will be then, n times 3/5 is 10. So you multiply by 5 and divide by 3, right? So n times 3/5 is 10. So n is equal to 10 divided by 3/5, which is 10 times 5/3 laps. So this is 16 2/3, not laps, 16 2/3 meetings. But there can't be 16 2/3 meetings. They would have met 16 2/3 16 times. And then they would have proceeded, and A and B are not together, after that. But the number of times they would have crossed each other would be 16 times. Right? So how many times do they pass each other after 10 laps? It'll be 16 times. You see, all these problems are a little bit tricky. So, but you have to think very carefully and try to understand what is being said. So you talk about passing each other. So therefore, we'll have to ask ourselves, what happens when they pass each other for the first time? Right? And then you will see, once you do that, then you can see how far has A traveled to get to that point. And you want, because altogether it covers 10 laps, okay? So it covers 3/5 after the first meeting, and there are several 3/5. You want to know how many 3/5. Each 3/5 will give you a meeting point. You want to know how many 3/5 are there in 10. Essentially, that's what you want to do, right? How many 3/5 are there in 10? So you have to divide 10 by 3/5. So that is what you got here. You see, how many 3/5 are there in 10? All right. So I'm doing many problems on distance time, and I must confess that they are not easy. I know you will think, oh God, all this is so difficult, but it's okay. I'm making you bite your teeth into tough problems. I'm doing many problems, so hopefully you will get the idea as to how one goes around solving these problems. But the main thing is you do it systematically, and eventually take all the information and record it systematically into numbers and equations, and then solve the problem. So this week's assignment, right? It's session 3, number 4. I'm not writing down the question. If you go into the problem book, go to session 3 and look at number 4, and that is your assignment for this week. Today is Thursday, so you can work on that assignment and submit it as you have done in the last 2 assignments. Hopefully, many of you are submitting it. I've been told that many of you are doing that. So please do that. Then at least I would know that you are benefiting in some way or the other from these lessons. Okay, so let's just go to the next question. All right, so this question here, given that now you got a big fraction here, 1 plus 2 plus 3, you got all odd numbers at the top, and then you got even numbers at the bottom, but you're adding all these numbers, and you get this fraction here, and you want to know what the value of n is, right? Okay, now we have sort of said something about this at some other time. So let's just give names to this quantity here. The numerator, let this be equal to x over y. Now I want to calculate what x is. Let's do x is equal to 1 plus 3 plus 5 plus all the way up to 2n minus 1. Now, how many terms have you got here? I think that's quite important to know. From the top there, you can't make out how many terms there are. But from the bottom, you can see how many terms there are, because you got, this is 2 times 1, 2 times 2, 2 times 3, and this is 2 times n. So it means you've got n terms here, right? 3 terms would have landed at 2 plus 4 plus 6. Right? So it finishes off at 2n. So the n numbers here. The dot, dot, dot means it goes on the same pattern. So the n terms at the bottom, n numbers, in other words. And at the top, you'll also have n, because you can see you can pair them off. You got 2 here, 1, 4, 3, 6, 5. So this top one is just 1 less than this. And here, 1 less than this is that. So you got whatever, the number of numbers here is the same as the number of numbers here, because you can pair them off. Right? They got the same. So this has also got n terms. The top has got n terms, and the bottom has got n terms. Okay, I'm going to calculate what this x is. We have seen this thing before, similar. Let me make this thing quite nice and large. 1 plus 3 plus 5 plus, now this dot, dot, dot means there are lots of other numbers in between, but the last one is 2n minus 1. Right. Now, whenever you have something like this, where you got the same, you're adding the same quantity all the time, right? To get to the next one, there's a simple trick which you can use, and that is write the same thing, but write it backwards. So now, if you start at 2n minus 1, plus the one before that, I'm not sure what that is, but it keeps going on, and you're writing it backwards. So you'll have 1 here, you'll have 3 here, you'll have 5. So if you write it backwards, it ends at 1, and it starts at 2n minus 1. Now, when you do that, then you can add these two, but you add it like this now. 1 plus 2n minus 1 is 2n. Now, the last one is 2n minus 1 plus 1 is 2n. Actually, it turns out that every one of them is 2n. You can try it out. Right? Every pair, 3 plus the second one, 5 plus the third term, they all will work out to 2n. The last one plus 1 is 2n. First one plus the last one is also 2n. So you got 2n, I'm sorry, it's added. They're all added to itself n times. 2n plus 2n plus 2n. And there are n of these things added. So 2n added to itself n times is 2n multiplied by n. 2n times n. Okay, so now you got 2x equals 2n times n, and this is 2n times n is 2n squared. So 2x equals 2n squared, so x is equal to n squared. That's interesting. So this thing here will be n squared. Now it's a very beautiful formula. We've just shown that when you add up all these things, we called it x, we calculated x to be the square of n. What does this mean? It means the following, that when you add the first odd numbers, if you add the first odd numbers, the answer is always the number of odd numbers you've got that you're adding, that's your n, and you square it. If you try it out, you'll see, if you try 1 plus 3, you get 4. Or 1 plus 3 plus 5 is 9. 1 plus 3 plus 5 plus 7 is 9 plus 7 is 16. I'll do one more. 1 plus 3 plus 5 plus 7 plus 9. It is 16 plus 9, which is 25. You see, here you got 2 squared. Here you got 3 squared. Here you got 4 squared. Here you got 5 squared. So this 2 is the number of terms here. 3 is the number of terms here. And 5 is the number of terms. So that is what you've got here. N is the number of terms squared. All right. So that's a very interesting formula, beautiful formula. Now, like that, you can try to work out y. Y is the denominator. It's 2 plus 4 plus 6 all the way up to 2n. Write it backwards. Y, the same sum you will get whether you write it forwards or backwards. You get 2n and so on. And it finishes up at 2. And then you got n such terms. So you add both of them. You got 2y. But now when you add this, you get 2n plus 2 plus and so on. And you see the last one is also 2n plus 2. And the n of these, so you're adding the same number n times. So it's n times 2n plus 2. If you add 3 5 times, you're going to get 3 times 5. So you're adding this n times. You're going to get this. So that's 2y. So therefore, y is equal to, you have to divide by 2. You can take out 2 as a common factor here. This is 2n into n plus 1. And so 2y is 2n into 2n plus 1. So therefore, y, you've got x is equal to n squared. And y is n into n plus 1. So it's a product of n and it's the number after it. The 2's cancel. So what we needed to calculate was x over y. So you got n squared over n into n plus 1. That's y. I'm substituting now. X over y. We had a formula for x, which is n squared. We had a formula for y, which is n into n plus 1. And then this is n times n, and this is n times n plus 1. So you can cancel the n's. And you will see that x over y is a fraction. And the numerator or the denominator is one more than the numerator. And if you look at this, you'll see the denominator is one more than the numerator. So this thing here is n over n plus 1. So straight away you can see what n is, because this is one more than that. So therefore n must be the numerator. So this is 2013 over 2014. So you can see by inspection, n is equal to 2013. So that was the problem there. Okay, I just want to say something here. I think I've got a little bit of time. So maybe today I went a bit too fast. I must apologize if I went too fast for you. This is, oops, what's going on here? Here's a very important formula. I might have mentioned this thing before, but 1 plus 2 plus 3, the sum of the first n natural numbers is n into n plus 1 over 2. So it's a very important formula. It's n times n plus 1 over 2. I think I've already done this, but I've forgotten. So if you got 2 plus 4 plus 6 up to 2n, you can take out 2 as a common factor, and it'll be 2 and this is the formula that I just said. This is 2 times, here you got n into n plus 1 over 2. Because the sum of the first n natural numbers is n into n plus 1 over 2. So when the 2's cancel, I could have got n into n plus 1, which you saw earlier on. When I calculated the denominator, I did get n into n plus 1. See? Generally, when you've got something with a common, where you're adding the same thing, like for instance now, suppose we did, sorry, what is 3 plus 7 plus 11 plus 15 and so on, and suppose it goes up to 103. Right, now suppose you had a problem like this now. You don't know how many terms there are here. There are different ways of calculating it, but normally what happens here is you got what we call an arithmetic sequence, because you got the same number added to itself each time to get the next one. Whenever you have that, it's an arithmetic sequence. So 1, 2, 3, and so on. That's an arithmetic sequence because you're adding only 1 each time. And 2, 4, 6 is an arithmetic sequence. This time we're adding 2. In this example, I've got 3, 7, 11. You're adding 4. Right? In each case, you're adding a fixed number, and you call that symbol D, whatever you're adding. The reason why you're calling it D is D for difference, because the difference between 2 and 1 and 3 and 2, the difference is the same. Even here, the difference between consecutive terms is the same. And here, the difference between consecutive terms is 4, 7 minus 3, and so on. And this is because it's the same, it's called a common difference. So whenever you have a common difference, then it's called an arithmetic sequence. And there are some very useful and important things to know about sequences like this, right? If I say A is the first term, and L is the last term, like here you got A is 3, and L is 103, right? And N is the number of terms. Right? So these are the three numbers which usually apply here. 4 numbers actually. You got A was the first term, D is the common difference, right? L for the last term, and N is the number of terms. You got symbols in general because you don't want to use this particular example, right? Then there are very interesting formulae regarding this. Right? Now you can calculate N here, but because they're growing by 4 each time, why don't I look at this one here? Start with 4 plus 8 plus 12. Start at 4, because you're adding 4. 16. Now here, it'll be one more than that. It's 104. Now here you can calculate how many terms you got, because this thing here has got the same number of terms as the top one. But you can count here, because this is 4 times 1, 4 times 2, 4 times 3, 4 times 4, and this is 4 times 26. If you divide that by 4, so the n, there are 26 terms in this, right? So if you know the first term and the last term, like what we got here, and the d, then you can calculate n, like the way I've done it like this. But then for this particular one, we were able to do it. But what about other ones? There's a very nice formula for this. I want you to write this thing down, take a photograph. There is a formula that links up the L, A, D, and N. You can always calculate the number of terms using this formula. N is equal to, right, you take the last term, subtract the first term, divide by the common difference, and add 1 to it. So in our example here, I could have had n. The last term is 103. That's your last term. The first term is 3. The common difference is 4. 103 minus 3 is 100. Or 4 plus 1. 100 divided by 4, I'm sure you know, that's 25. And 25 plus 1 is 26. Right. So you always will get the number of terms by this very useful formula. Now, this they don't teach you in school, but I want you to remember this formula. It's a very useful formula, which comes up quite often. Okay, and now there is another important thing. When you're adding up this, what's the sum? That looks like a rather complicated thing. Now, how do you work out the sum? There's a very simple formula for the sum, for the arithmetic sequence. The formula is sum of n terms of an arithmetic sequence. When you're adding, you don't say sequence, you say series. Because you're making sum. It's this. It's equal to n times the average of the first and the last terms. The sum of n terms of an arithmetic series is n multiplied by the average of the first and the last term. So in this example here, you got n is equal to 26, we calculated. The average of the first and the last terms is 3 plus 103 divided by 2. So you can work this thing out. It's 106 divided by 2 is 53. And so that if you work out, it's 1,378. So you can actually work out the sum of all these things using this formula, that the number of terms times the average of the first and the last terms. Now, let's apply what we just said now to the simple formula here. 1 plus 2 plus 3 plus n. Right. How many terms have you got here? N terms, you can see it, multiplied by the average of the first and the last terms. That's 1 plus n divided by 2. And that's exactly what we had, the n into n plus 1 over 2. So you can apply what I just told you here. The sum of this is n times the average of the first and the last terms. And in the other case, 1 plus 3 plus 5 up to 2n minus 1. There too, we said the number of terms is n. The average of the first and the last terms is 1. That's the first term. The last term is 2n minus 1. And we're going to work out the average of those two. And the average of those two is that 1 plus first term plus last term. But when you look at the thing, you can simplify it. At the top there, you've got 1 minus 1, and you've got 2n. So it's n times 2n divided by 2. The 2's cancel. And lo and behold, you've got n times n. It's n squared. So these are special examples of this nice general formula. But you can apply it to anything like that, like the way we did it here. All right. So I just went into a quick run into arithmetic sequences. Whatever I've told you now is all very useful. And hopefully, you will go over it. The recording will be sent, will be posted, and you can go and read that thing, and you learn something very nice about sequences like that. How you can add any number of terms. Well, look at that. So many terms, you can just got a nice simple formula for it. Okay, so to get back to our problems. This is what we did last, and we finished with that. Now, let's look at number 10. Yeah, you got a funny thing. No, wait a minute. Yeah, this is what we got. Yeah. Now, let star of x, now this is a funny thing, be the sum of the digits of the positive whole number, x. So you got a whole number, and we are saying that the star of that whole number is the sum of the digits of the whole number x. Let's take some examples and see what's being said here. So star bracket. Now let's put this is a whole number, positive whole number. Say x is equal to 326. That's an example of a positive whole number. Now with close brackets, so star bracket, we read this in as star of. And this is equal to the sum of the digits. The 3 digits here is 3 plus 2 plus 6. So the answer is 11. So star of 326 is 11. So like that, you can work out star of anything. Star of 41 is 5. Star of 100 is 1. You simply just add up all the digits, and the star of that, and so on. Right. Now, we've understood what the star means. Now they say, for how many 2-digit numbers x? Now here you got a funny thing here. You got star of x. That's this part here. And then you take the bracket of that, and you got the star of that. So it's the star of the star of x. Now that's making it a little bit complicated. Now suppose I had x is equal to 5,993, for example. Let's calculate this. Star of x first is 18 plus 8, which is 26. And now we are looking at the star of that one. So the whole thing here, it goes into this outside bracket. And that is, we calculated the inside one to be 26. So therefore, this is 8, 2 plus 6. Star means you're adding up all the digits. You've got a double star, you add up all the digits, and then you add up the digits of the answer. Okay? So that's what you've got here. And now the question is now, you got double star of x is 3. So when I work out the star of this, I get 3. The star of this. Right. Star of 26 is 8. The star of 53 is also 8. The star of 332 is also 8. Right? Now, we know the star of this is 3. So you got the star of x is 3. So what are the possible values for x? And it's a 2-digit number. No, I'm sorry. The star of this is 3. So what do you think the star of x will be? It will be equal to, when you add the digits of star of x, that's what you got. You're adding the digits of star of x, you're going to get 3. Right. So when you add the digits of star of x, you're going to get 3. So what are the possibilities? You could have star of x, could be quite a few possibilities. It could be 111, or it could be 21, or it could be 12, or it could be 30. So the different ways of getting this, or it could be even 3. Right? So the star of this quantity is 3. So these are the possible values for this quantity. Right? Okay, so now the question is now, how many 2-digit numbers? We are solving for x now. So if you work out, the x is a 2-digit number. X is a 2-digit number. Now, what does that mean? What's the largest value of x, star of x? Right? You got a 2-digit number. If you keep adding up the digits of this, the largest possible answer you get is 18, isn't it? 99. All the others will be smaller. So whatever x is, the largest value of star x is 18. So therefore, you'll have to eliminate that one and eliminate that one. Because star of x can't be 111, can't be that, and it can't be 30 also. So, because the largest possible value you can have is 18. So you get a star x is equal to 12, or star of x is 3. It's a 2-digit number. Right. Now, for star x to be 12, a 2-digit number, what are the possibilities? Right. You can't have 1 in it. You can't have 2 in it. You can't have 3. So you got to have 3, 3, 9, 9, 3, 4, 8, 8, 4. What is 5, 7, 7, 5, and 6, 6. See? So these are the 2-digit numbers whose star is 12. And when you work out the double star, you will get 3, because all of them gives you star is 12. And the star of 12 is 1 plus 2, which is 3. So these are the possibilities. And in this case here, if star x is equal to 3, then you could have 1, 2, Right? Now you're adding these numbers to get 3. So you could have 12, or you could have 21. It has to be a 2-digit number, but it could be 30 also. Right? It can't be 3. Right? So because 3 it has to be a 2-digit number. So now these are the only 2-digit numbers which will satisfy this equation. Yeah? You just have to understand exactly what you mean by star X, and when you're working on the double star, you have to understand that you have to work out star twice. Okay, and then when you solve for X, you get quite a few solutions. I see there are 10. How many different 2-digit numbers there are? You don't have to write them down. They want to know how many there are. Always answer the question, and you see there are 10 2-digit numbers. Okay, and then finally, okay, then I'm going to do the very last problem. If A, B, and C are positive integers such that this thing is equal to 30 over 13, what is the value of A plus B plus C? Now, if you haven't seen this thing here before, then it can be very hard because you've got 3 unknowns here, A, B, and C. And it's a very messy kind of a thing because you take 1 over and then you got B and 1 over and so on. And you got 30 over 13. And how do you calculate A, B, and C? You need to calculate that. Actually, you need to calculate the sum of the 3, right? But whenever you see anything like this, there's one way of doing it, and it's a very easy solution. But if you haven't seen it before, then it can be very hard. And watch. Whenever you got a thing like this, what's really happening is that this is an integer. So you want to work out 30 over 13. 13 goes into this 2 times. 26, 26, remainder 4. Right? So now that is, I got A plus. So let's make the thing as 2 plus 4 over 13. Right. So it looks as if A is equal to 2. Right? Now you want to write 4 over 13 like this. Right? So let's write down 4 over 13. You want to write it like this. Now you're going to write it as a fraction with 1 at the top. So what will you have at the bottom? See? So this is your A. And this part here is 4 over 13. So I got 4 over 13 is 1 over something. Right. But what shall you put at the bottom to make this thing 4 over 13? The answer is 13 over 4. When you divide 1 by 13 over 4, you switch it around. So now you got 1 over, and now you got 4 goes into 13. This bottom part is 3 1/4. So it's 1 over. Now you see, you got the integer now, 3 plus 1 over 4. And there we got it. You got B, 3 plus 1 over 4. So this part here is 2 plus, I've just worked out 4 over 13. I first had to do this and then wrote that as an improper fraction and wrote it like this so that I've got my eye fixed on the problem. So you got 2 plus 1 over 3 plus 1 over 4. So you got it exactly in that form. So now you got A is equal to 2, B is equal to 3, and C, 1 over C is 1 over 4. And the question, what is A plus B plus C? That's the question. It's 2 plus 3 plus 4, and that's 9. So guys, that's the last problem. that we have done here. And I know I went quite briskly, but please, the recording will be available. If you want to go back to that, try to go back and if you didn't understand anything, you can go to that, and you got all the sheets are there in front of you, so you can see what the calculations are. All right. We don't meet next week because for some reason, but the next time we meet will be not next Thursday, but the Thursday after that. Right? So next week you'll have a break, but there is a homework problem, right? It's the section 3, the junior section in the book, and it's number 4. So you've got enough time to solve that, but maybe not enough time. Go and look at your post to see when you are supposed to be handing in your assignment. There's a deadline, because and even there's a deadline for how long the recording will last. If there are some people who didn't attend, tell them that the recording will be wiped out in a few days, I think 5 days or so. Right. The recording is not kept there permanently. Okay, so thank you very much for attending. And I will take any questions. If anybody has got any questions, please remain behind. And the others can leave. And thank you very much for coming. And I will see you in 2 weeks' time. Okay, if anybody got any questions, any remarks, you can stay behind and ask me. I'll be only too happy to answer it. Okay, there is one question in chat. How can I get the page of the homework since I don't have the book? Oh, the book was given to you. It's called Problem Book. David, can you answer this?
Yes, Prof, we did send the book to all the organizers. Maybe you need to check with the organizer for that center. And then for KZN is Mark Ancelotti, and then for Limpopo is what's that say name?
Yeah.
Yes.
No, this is very unfortunate. Now, he's got the book, but they haven't sent it to the students. So in other words, these students didn't even go through the problems. Anyway, I think I don't know that I have the list of all. Londani, put your mic on, please.
Hello.
Yeah. Londani, are you from Limpopo?
Yes, I'm from Limpopo.
Oh, all right. So
are you on the WhatsApp group? Are you on the WhatsApp group?